What do you mean by increasing function and decreasing function? So the concept of derivatives plays a very crucial role in understanding the increasing and decreasing of a function. So as I told in an example, a curve can be constantly increasing or decreasing at every instant, right? So suppose, what do you mean by increasing function? Let I be an open interval contained in the domain of a real valued function f. Then f is said to be increasing if this condition literally is applicable. That is, what is the condition? When x1 is less than x2 and f of x1 is also less than or equal to f of x2, that means x is increasing along with the y, that is increasing function. It is strictly increasing. See, in this case, either or, but it is strictly increasing if it is only increasing but not r. So either r is not there here, right? So f of x1 is less than f of x2. Similarly, for a decreasing function, what happens is in an interval, function f is said to be increasing or decreasing if the opposite condition happens. That is, f of x1 is nothing but what? Y1. If y1 is greater than or equal to y2, when x1 is less than x2, then it is decreasing function. So like this. Okay. Sometimes what happens? Strictly decreasing function in a case where it is not either or, but it is just greater than. So if y1 is greater than y2 when x1 is less than x2. Indirectly, this all comes to differentiation concept only. That is, let me show you. Rate of change of y with respect to x. So f dash, what is f dash? Derivative of f with respect to x generally is an increasing function. F is an increasing function in the closed interval a comma b. Closed interval, it's called closed interval. If the derivative of the function is greater than 0, that is f dash of x or dy by dx is greater than 0 in the closed interval a comma b. Okay. Similarly, if f dash of x is less than 0, then f of x is, what is it? Is a decreasing function in the open interval a comma b. If f dash of x is directly equal to 0, now the function is neither increasing nor decreasing in the interval, closed open interval a comma b. That's the meaning. And how are we going to use this? Let's solve some questions to understand the usage of this. Okay, shall we? Any doubt in this? Prove that the function given by f of x is equal to 7x minus 3 is an increasing function. First of all, let me not use the integral differentiation part. Instead, I'll show you this graph directly. So what is the slope of this graph? Is it positive? Let's think about, can you recall equation of a line in the form of y is equal to mx plus c form? Yes, y is equal to mx plus c form. So in this question, we have y is equal to 7x minus 3. So what is the y-intercept here? Minus 3. So if I had to plot the values here, this is minus 3. And what is the slope? 7. That means I can tell x-intercept, right? Y at x-intercept, y is equal to 0. Then x is equal to what? 7 by 3. Sorry, 3 by 7. Excuse me. It is 3 by 7. Positive or negative? It is positive or negative. So when y is equal to 0, what happens? 3 goes to that side, 3 by 7. So why is 3 by 7? 3 by 7 is less than half or more than half? It is less than half. So it is between 0 and 1. So it's somewhere here. And the line will be like this. Let me, somewhere between 0 and 1, this will be there. So what is the exact value of 3 by 7? Do you know what is the exact value of 3 by 7? It's going to be around 0.42. I don't want to explain the value of this right now, why, how, and all. So this is the non-terminating number. So it's somewhere here. And when you join this line, you get a line like this. Is it increasing line or decreasing line? It's an increasing line. As it's increasing line, it has to be an increasing function in the real number. Okay, that's practical way or graphical way of understanding this. But using our differentiation concept, how are we going to do this? So let me write y is equal to what? 7x minus 3. What is dy by dx? Dy by dx is simply 7. Now is it greater than 0? Yes. As it is greater than 0, definitely our dy by dx is going to be always positive, and it's always an increasing function, strictly increasing, not greater than or equal to 0. It's clearly greater than 0, right? Next question. Let's look at the next question. Yes. What is it? Prove that the function given by f of x is equal to minus cos x. We have multiple sub questions. Is decreasing in the interval 0 to pi by 2. Okay. First, let us see how this function operates in the four quadrants. Okay. Again, practical aspects. After that, we'll use the differentiation concept. Okay. So this is the interval here. In case of trigonometric, this is the first quadrant. Here all are positive. Here sine is positive. Remember this, tan and then cos is positive. And they're telling f of x is equal to minus cos x. Okay, in the interval 0 to pi by 2, cos x is positive, but minus cos x is, in this region, minus cos x is what? Negative. Yes or no? So what is cos 0? Cos 0 is 1. Cos 30 is, what is cos 30? 1 by root 3 by 2, right? Cos 45 is 1 by root 2. Am I right? Yes. Cos 60 is 1 by 2. And cos 90 is 0, right? If I want to show the graph of the cos curve from 0 to 90, it is coming like this. This is 0, this is 90 degree. It is actually from 1, it has become 0, right? So is it decreasing? Yes, it is decreasing practically. Okay. Now coming to increasing function. They're saying it is increasing from pi to 2 pi. Pi to 2 pi means, so this is 90 and it is 180. At 180 it will become like this. It will reach minus 1, and from 180 to 360 the curve will be like this. Okay, so isn't it increasing? Yes, it is increasing from 0 to 180 to 360. This is proved practically. Okay, it is neither increasing or not decreasing in the interval 0 to 2 pi. 0 to 2 pi means, where is it? Neither increasing nor decreasing. So the last part we have to understand, is it increasing? Neither increasing nor decreasing means from 0 to 2 pi, here to here, what is happening is it is decreasing and increasing, but from 0 to 2 pi the value remains same at the end, right, in the open interval. So let's see how they're using differentiation for this concept, shall we? Yes. First, we have to find f dash of x. What is f of x? Minus cos x. What is f dash of x? Let's minus b as it is. Again, minus sin x, which is plus sin x. Okay, and sin x between the intervals, which interval? 0 to pi by 2. What happens to sin x is 0 to pi by 2. It is always going to be what? Positive. Sin is positive again in the first interval. Sin is always first quadrant. Sin theta is always positive. So that means f dash x is greater than 0. So it's positive. Second interval 0 to pi to 2 pi. Sin x is negative. So it is decreasing. Correct. Whereas by from this to this, it is increasing as well as decreasing. So I cannot say clearly increasing function, clearly decreasing function, because it is varying with increasing as well as decreasing, right? So that's how we get this. Is it making sense? From 0 to pi, I can say pi to 2 pi, I can say, but 0 to 2 pi, it is both increasing as well as decreasing. That's why I cannot give a conclusion clearly increasing, clearly decreasing. So it's neither increasing nor decreasing function, we can say. Okay. Look at this question. What do we have? The median of an equilateral triangle is increasing at the rate of 2 root 3 centimeter per second. Find the rate at which its side is increasing. First, we need to know the area of equilateral triangle. I told you what is the area of equilateral triangle. Area of equilateral triangle is root 3 by 4 a square. And what is the median? Median is also height in this case, which is root 3 by 2a. Yes or no? Yeah. So what is the rate at which the side is increasing is the question. So the median is increasing at what rate? 2 root 3. So we'll differentiate this first. dh by dt is what? Into dA by dt. Am I right? So this is given as 2 root 3. So we're going to substitute the values. So we'll directly get the side at which it is increasing. So root 3 cancels. What is dA by dt now? dA by dt is 4 centimeter per second. If the units are in seconds. Yes. So that's the answer for the first question. Okay. So second question, we don't need to do this because it's not part. It is the talking about maximum and minimum. We'll come to that later. So let's go to the next question quickly. Yes. If f of x is equal to a tan x minus minus cot x, where a is greater than 0, find whether the function is increasing or decreasing. So I had to figure out whether the function is increasing or decreasing. So for the function to be increasing, f dash x should be greater than 0. For an increasing function, I'm reiterating this part again. And if f dash of x is less than 0, it's what? Decreasing function. So let's see what is happening. So what is f of x? F of x is a into tan x minus cot x. And they are told clearly a is greater than 0. So let us differentiate with respect to x. A into secant square x. Remember, differentiation of tan x is secant square x minus of minus cosecant square x. So what is happening to our expression? A into secant square x plus cosecant square x. So can you understand, is it positive or negative? That wrote clearly a is greater than 0 and secant square of any number is always positive and this is always positive. Okay, but this or it can be even 0, right? So as it is, as a is always positive and this cannot become negative, so the product is either positive or 0. So in that case, the given function is increasing function. I may not say strictly increasing because it might even become 0. Can it become 0? Secant and cosecant, what is the range? Secant and cosecant curve will not reach 0 as well. Okay, they'll be either positive or negative, so they will never reach 0. As they don't reach 0, this will never become 0 as well. So, and the square of the negative number or positive number is always positive. So it is strictly not just increasing, it is strictly increasing function. See how much knowledge is required for this simple question. I need to know the range of secant. I need to know the range of the cosecant. I need to know the concept of increasing or decreasing function. I should also know how to differentiate secant and cosecant, right? All of this must be required to answer this question accurately. Okay, it is not just I'm going to behead this particular rule. So I'll differentiate and answer. If I know the graph of secant and cosecant and the range and the nature of that, it will be easy. And from the 11th standard, we are learning trigonometry and we learned inverse trigonometry. We know the range, domain, all that. So we cannot tell now it is something very difficult to understand. So the flow of the concept has been very clear from 11th to 12th. So if you have followed that, all that in a right order, you will not face any difficulty. Okay, so let's go to the next one. Question number 3. Show that function f of x is strictly decreasing in the region. So let's differentiate this first quickly. Y is equal to 16 sin x divided by what? 4 plus cos x minus x. So what is the differentiation in the quotient form? We'll differentiate the denominator first. Minus sin x into 16 sin x. Let me erase this. Let me make a space. So d by dx of the given function is 0 minus sin x into 16 sin x minus 4 plus cos x into 16 cos x. Right? Yes. Divide by 4 plus cos x whole square minus 1. When I solve this, I get minus 16 sin square x, right, plus cos square x. I'm going to write that here, minus 64 cos x, and I'm going to bring this here, minus of 16 plus cos square x plus, there's a plus b whole square format, 2 into 4, 8 cos x. Am I right? So this entire thing divided by 4 plus cos x whole square, right? So if I solve this further, this is minus 16 into, this will be 1, minus 16 cos square x, correct? And then minus 64 plus 8 is minus 56 cos x divided by 4 plus cos x whole square. So the denominator is going to be positive. That's very clear for us. So it's going to be, cos x can become 0 or whatever. At the end, whatever the value, square of that is going to be positive. So I am ending up with minus 16 common. That is 1 minus cos square x. 1 minus cos square x minus 56. What is 1 minus cos square x? That is nothing but sin square x, right? Minus 56 cos x divided by 4 plus cos x whole square. So this will be again positive value. So minus 16 into this is negative. And what is cos x? What is cos x? Between pi by 2 to pi, cos is negative. Am I right? Yes. Pi by 2 to pi, cos is negative for sure. So this will become negative. Am I right? Yes. So this will remain negative and this part is positive. So at the end, the value will be negative in the numerator. The denominator is positive. Negative by denominator positive is going to be negative only. So that's why it's been proved that f dash x is negative. So this will be strictly a decreasing function. No doubt in that. Okay. So let me go to one last question in this. Then we can go to the next part and the last part of this section, which is maxima and minima. Okay. It's an assertion reasoning question. Let's see the assertion. The assertion says log sin x is a decreasing function in the interval 0 to pi by 2. So let's differentiate and check. Shall we? Yes. So what is d by dx of this? Log sin x, which is 1 by sin x into cos x, which is actually cot x. Sir, no. In the interval 0 to pi by 2, what is cot x? 0 to pi by 2, cot x is positive, right? Isn't it? Is it decreasing or increasing function now? That means the assertion is wrong. 0 to pi by 2, everything is going to be what? Positive. So that means this assertion is wrong. As assertion is false, I cannot look at any of these options because all these options says assertion is true. That means the answer should be D itself, right? Yes. What about reasoning? We don't have to get into reasoning part at all now, but reasoning must be true for that. What is reasoning says? A function f of x is said to be increasing function in the interval a to b if f dash x is greater than 0. Yes, that is actually true. That means my answer is clearly option D. Assertion is wrong, reason is true. Okay, let's go to the next one quickly. Yes. Assertion function is given as function sin x and cos x both are decreasing in the interval pi by 2 to pi. Is it true? From pi by 2 to pi, are they increasing or decreasing? Let's see. What is d by dx of sin x? D by dx of sin x is cos x. Yes. And cos x from pi by 2 to pi, is it positive or negative? Cos x from pi by 2 to pi, it is negative. So that is decreasing function, correct. What is d by dx of cos x? Minus sin x. Minus sin x, is it true? From pi by 2 to pi, what happens to uh, minus sin x? Sin x is positive, so minus sin x is negative. Yes, that is also correct. Sin x is positive in that interval, minus sin x is negative. So both are decreasing, correct. Assertion is true. As assertion is true, option D cannot be taken, can be ruled out. Derivative of a decreasing function is also decreasing in the same interval. Is it true? Does it have anything to do with this question? No. That means uh, assertion is true. Let's see the reasoning is false. Or we can give a logic for that. Is this true, that statement? So it says reasoning is the right explanation of the assertion. So let's look at the explanation part and understand this. The derivatives of sin x and cos x are cos x and minus sin x respectively in the interval pi to 2 pi, and both cos x and minus sin x are negative. So the reason supports the assertion by confirming that derivative of sin x and cos x are negative in the interval. That means whatever the reason is giving is supporting the assertion. The reason is a proper explanation of the assertion. That means we can remember this part. Derivative of a decreasing function is also decreasing in the same interval. Yes, in this case, for this particular situation, it's correct. It cannot be taken as a general rule. In this case, it is happening. That's why it is still true. Okay, let's go for the last question in this section. So what is this? We have to choose the right option here. F of x, which is given by what? X power 5. Is it visible? Let me increase the size. X power 5 minus 20 x cube plus 240x. Okay. Which of the following are right? It is monotonically decreasing everywhere. Does it monotic? What is meant by monotonically? That means completely throughout the range. Is it decreasing in this interval, or is it monotonically increasing everywhere, or does it monotonically increase in only in this interval? So let us directly go to the solution and answer because we don't have much time. So what is the solution saying? Let's have a look at it quickly. So it is saying option C, it's monotonically increasing everywhere. Why it is increasing everywhere? So when you differentiate this, what happens? Let's see. So when you differentiate this, we get 5x power 4. Then it will become minus 60 x square plus 240. Okay. So everywhere means what? If x is equal to 0, it's positive. Okay, if x is equal to 1, it is, so in case of negative, a 240 is always higher than this number. So even if it becomes negative, this will become positive at the end. That is the reason f dash of x is always going to be 0. So it is monotonically increasing everywhere. So that is the reason. Okay. Yes.